Okay, so today we are going to discuss about integration. So first of all, we will discuss what is the meaning of integration, physical meaning. Okay, what is integration? Integration of y with respect with respect to x from from x equal to x1 to x equal to x2. What is the meaning? And x equal to x1 is called lower limit, and x equal to x2 is called upper limit. Okay. So what is the meaning of this integration? Okay, so integration is represented by this symbol y dx, integration of y with respect to x between the limits, so x equal to x1 to x equal to x2. What is the physical meaning of this integration? So there are two ways which we can understand the meaning of integration. Let us understand the first. What is the first meaning of integration? So the first meaning of integration means it is a process which is exactly opposite of differentiation. It is opposite of differentiation. It is a mathematical process or a mathematical tool, right? So let's understand this meaning. First is integration of y with respect to x. Integration of y with respect to x as opposite of dy by dx. Integration, the process of integration is opposite of differentiation. Let us try to understand this. So first thing is, what is differentiation? Let's take with example. Suppose if I am going to differentiate x square with respect to x square differentiation with respect to x. Here x square is the function, that means y is x square. So differentiation of y with respect to x, we have the idea what is dy by dx. It is the slope of the tangent. So if I take y as x square, and we know what do we get? We get 2x. We get 2x, right? So this is what is the differentiation. But suppose if I take 2x, let us take 2x and integrate it with respect to x, we will get back x square. And of course, there is a limit also. How to put that limit, that we will see. But if you are not taking the limit, this is called indefinite integration. Indefinite integration means without limit. Indefinite integration. Indefinite integration means without limits. Without limits. And definite integration means definite integration means with limits. With limits. That means we have upper limit, we have lower limit. But indefinite means they don't have any limit. So whenever you do indefinite integration, note that whenever you are performing indefinite integration, we add a constant. We add a constant. So this constant is called the constant of indefinite integration or constant of integration. So whenever you are performing without any limits that integration process, you will of course get the value which is exactly opposite of differentiation. Because when you take x square and differentiate, you get 2x, and when you take this 2x and integrate with respect to x, you will get back x square. But if it is an indefinite integration, we'll put a constant. But if it is a definite integration, we will solve it, we will evaluate it, right? And how to evaluate it, that we can understand. Let us try to this understand how to evaluate. Evaluation, how to do evaluation. So suppose for example this you want to evaluate 2x dx between the limits x equal to 1 to x is equal to 2. So you need to use the same formula. The integration of this 2x with respect to x will give x square only, x square, but we will write it a square bracket with x equal to 1 and x equal to 2. Now we will substitute the upper limit first. So in this you substitute upper limit. Upper limit is substitute value of x, upper value. So x2 you substitute, so 2 square minus, then lower value, lower limit of x 1, so 1 square. So you got this as 4 minus 1, which is equal to 3. So this is what it is. So when you solve a definite integration, you will get a particular value. There won't be any constant of integration. But when you are performing indefinite integration, there is going to be a constant. Why? Because you do not know the limit. That's why if suppose limit changes, then there will be some particular value. So that is why a constant has been added, so that if you have to put certain limits, then the constant may not appear, it will not come. Okay, so this is the process how to evaluate a definite integration. Formula is going to be same, but we need to one time substitute the upper limit minus, next we have to substitute lower limit, right? So that's how, this is one of the meaning, it is opposite. So that means all the formulas of integration are opposite of differentiation. So let us now try to review or revise the important formulas. Already you know that. So let us do that. Here itself you will understand the formula. So let us know this, some of the formulas. So integration of x power n with respect to x becomes x power n plus 1 by n plus 1. This formula you can use, provided, and of course constant we add because it's indefinite we are using. But note that here this n should not be equal to minus 1, because if n becomes minus 1, this will become 0 in the denominator. So otherwise, if it becomes 0 in denominator, means it will become not defined. So that is why we cannot keep n as minus. That means here n power should not be minus 1. So for that we have to especially think about it. So think about it. Suppose it is x power minus 1 dx. That means it is nothing but integration of 1 by x dx. When do we get 1 by x in differentiation? Think this the reverse way. When do you get differentiation as 1 by x? When you are differentiating ln x, right? So ln x differentiation gives 1 by x. So 1 by x integration will give ln x. That is how you will get. Of course, you will add one constant of integration. Like that. Next, let us write formulas. Next formula. Let us write next formula. So let's take trigonometric functions. So differentiation of sine x with respect to x is equal to cos x. So just you apply this integration. Integration of cos x with respect to x becomes sine x, plus constant of integration we can add. Next, put the different formula. Next, differentiation of cos x with respect to x is equal to minus sine x. Okay, cos x differentiation is what? Minus sine x. So integration of sine x with respect to x will give us minus cos x plus constant of integration. Let us go for another formula. Differentiation of what is tan x differentiation? Tan x differentiation is secant square x. So that is why integration of secant square x with respect to x will give us tan x. plus constant of integration. Similarly, sin cos tan is over. Then can we take next? What is differentiation of cot x with respect to x? That is minus cosecant square x, right? That is why integration of cosecant square x with respect to x becomes minus cot x. Minus I am just bringing this side, other side. But there must be minus because here minus is involved. Then next, cosecant x. Cosecant x differentiation is minus cosecant x into cot x. That is why integration of cosecant x cot x with respect to x gives us minus cosecant cosecant x cosecant x. This correct? Check that. Cosecant x will give, right, plus constant. Then what? Next, so cot is equal to cosecant. Secant is remaining secant. So differentiation of secant x with respect to x is secant x tan x. So just the reverse, if you take secant x tan x with respect to x integration, give us secant x plus some constant of integration. So we must remember this formula, but beside this there are many other formulas which you have to remember. Starting with basic formulas, we can try questions. Okay, these are integration of trigonometric functions. Then similarly, you can think of log function. Let us say next. Let us take log. So integration of uh, so you think like this with differentiation. First you think, what is differentiation of a per power x with respect to x? That is a per power x ln a, right? A per power x ln a. So the integration of a per power x with respect to x will become a per power x divided by ln a plus constant of integration. So here ln a was multiplied, here ln a got divided. Okay. Then and also note here that if it is just e per power x, so e per power x differentiation with respect to x is e per power x only because ln e becomes 1. So that is why integration of e per power x with respect to x gives us e per power x only plus constant of integration. Like this, right? So many rules will be there which we need to remember that. Okay. So we have seen these important formulas and what is the meaning of integration as the opposite process of differentiation. Now let us understand the second meaning of integration, which is very important, and that is what is the physical meaning of that. Okay. So let us understand the second meaning, which is the physical meaning, physical meaning, physical meaning of integration y dx between the limits x equal to x1 and x equal to x2. What is the meaning of that? Okay, so let us do that. So if I want to do this integration, let us understand graph again, because just like you have studied graph to understand the meaning of dy by dx slope, you have started from graph. So the concept of integration also comes from graph. Okay, so let us say that there is a graph, some kind of graph is there. Again, of course, this is a function only. Always we are studying functions because functions are something which is unique, right? Unique kind of relationship. That's why function is important. So this is a function, of course, it will be like this way. Okay? Some function is there, let us say. And I want to find out area between between this point. This graph is there, but this is, let us say, x is equal to x1 and this is x equal to x2. So this is lower limit, upper limit. We want to find the area below this graph. Okay. Area under the graph. Area under the graph or below the graph. Between x equal to x1 and x equal to x2. This area we want to find. This is a function. This y is equal to f of x is a function. So what we need to do is we can try to break this into small strips like this. Okay. So try to break it into small strips. Right? We keep on breaking it, but note that the width of each uh, strip has to be kept as same, like this. Okay. Some rough idea we will get between that. Okay. So each width, each delta x. Okay. So if you focus on each, it is almost like a rectangle delta x, and let us say this is y. So let us consider this is the element whose position from origin is x, and at that value of x there is value of y, and delta x is the change in the x. So this is the strip you are taking, right? So as you change x, the position of this strip will be different. Suppose you take lower limit, so x will be equal to x1. So at x equal to x1, that will be strip. Similarly, at this side also we will have a strip. So you are going to divide this entire area into small strips. And area of this strip, let us call it as delta A. That area is y into delta x, right? And suppose I want to calculate the total area, we can try to calculate the sum of all these areas. So net area, if I want, we can try to do the sum of all this delta A. But you know the problem what will happen. There is some areas which will miss out. Suppose for example you take this area, then next area you take, then next area you take, like this. When you will be taking up all this area, you'll find that some areas will be missing out in this process. You know where those areas are missing? I think you can see in this diagram. Somewhere, while taking the areas of this strip, somewhere it is missing out. Rough diagram it is. So clearly you can see that there are some, strips, some area which is like a triangular area is getting lost here, right? You can see this small triangular area, we are not able to add them because of some problem, because our strips is not, including that. So that's the limitation of this process which you are breaking into delta x strip. So instead of doing that, if you make a very fine strip, that means this delta x must be very small, so almost it is like 0. So if you apply the condition of limit, just like in differentiation, we have applied the condition of limit, then you will get the exact area. This area is going to be approximate area. You can say approximate area, but this will be not the total area. You can calculate, but this will not give total area. Why? Because some area will be left out. So this will not give area. But if you want to exact area, you need to better do this summation, but you need to keep on adding continuously for very small thickness. So that is what we are defined as integration. Yes. So the integration process is nothing but summation. So it is like a summation process, but in this summation we are applying the limit condition delta x tends to 0. That's the summation, right? So when you apply this limit over this summation by keeping this condition delta x tends to 0, then that is what is called integration. That is what is called integration. Okay. And here we put limits. The limit we can write separately, x equal to x1 to x equal to x. So that is the physical meaning of integration. So you will take a small element y into dx, and the position of this element will be x. X is the position of this element, right? And this element is almost going to be like what? Like a very thin line. Very thin line it is. Now when you divide into small line, there won't be any left out areas. So that's how we calculate this. A small area dA we calculate. dA is y into dx, and then you are integrating it. You will get the total area. Of course, you have to put the limit from x equal to x1 to x equal to x2. That is the meaning of integration. So integration gives us the area below the graph area between that graph and x-axis, and between the limits x1 to x2. That's the physical meaning of that, right? That's a very important concept. Done. So this is what is the area meaning, and now we can see for different graphs we have different meanings of the areas, right? Let us take some of the graphs and we can see the meanings, right? What is differentiation, what is integration in that. Both applications now we can see. So suppose if I start with kinematics and some other graphs of dynamics also we will see. Suppose it is position time graph. Let us say there is a body which is moving and x represent position from origin, right? X is the position, and right now time is equal to t. Time is t, position is x. So if I draw this xt graph, position time graph, if I draw, let us say this is like a graph. So what is the slope here means, suppose if I take a point and I draw tangent, this tan theta is the slope. Slope means dx by dt. This gives us velocity. Velocity means it is instantaneous. Instantaneous velocity. But if I take secant line, remember secant line means we have to take a chord like this. So if you take a chord which is a secant line, it will cut the graph at 2 points. So here this is going to be delta x by delta t. This is delta x and this is delta t. So that can also be, let us call that as theta dash. So tan theta dash will give us delta x by delta t. That will give average velocity. Remember, this is average velocity. So if it is position time graph, this is the slope of tangent gives and this is the slope of secant. What is tan theta here? This is slope of tangent. And this is slope of secant. So area does not have any meaning here. So if you take position time graph, you can only understand slope, whether instantaneous slope or average slope. So instantaneous slope will give instantaneous velocity, average slope will give average velocity, right? Okay, coming to the next. Suppose if I take VT graph, let us take velocity time graph. If you take velocity time graph here, let us think about it. Same manner you can see. If I take a tangent theta, this is tangent line. So slope of tangent, which is tan theta here, which is dv by dt, will give us instantaneous acceleration. But if I take here also, if I take secant, secant means this graph will cut at more than 1 point. It is coming here, here it is cutting. Again, you take this as theta dash. Okay, so so if this is secant line, secant, so slope of secant is tan theta dash, which is delta v by delta t, which is nothing but average acceleration, right? So average acceleration can be calculated from here. But now let us understand what is the area of this graph. This graph area has applications. So what is the meaning of integration of v dt? That is what is area under this graph. Under velocity time graph, integration of velocity with respect to time is area. What is the meaning of that area? Let us see now. So here we can say velocity as dx by dt, and this is dt. So dt will get cancelled. It is integration of dx. Integration of dx gives us total displacement delta x. So integration of velocity with respect to time gives us displacement. We have to remember that. Okay. Remember integration of v dt, of course between limits, time limit, that will give us delta x, which is called displacement. Displacement. Okay, this we need to remember. So now you see the area under graph has got importance according to different type of graph. This is velocity time graph. So in velocity time graph we have area. Area of velocity time graphs gives displacement. So let us see next. Let us take about the next acceleration time graph. This is acceleration time graph. Here also, if you want to study, you can study the slope, right? So you can take a tangent, tangent. So this is theta. So tan theta, which is the slope of tangent here, slope of tangent, that gives us rate of change of acceleration dy by dx, a by dt. This is called instantaneous jerk. It is called a term called jerk. Similarly, if I call or if I make a line which is secant, of course we have to show it is cutting at 2 points, right? Let us show that it is cutting somewhere. So it is cutting at these 2 points here and here, and this is theta dash. So this line is a secant line. So slope of secant here is nothing but tan theta dash, which is delta A by delta t. This delta A by delta t is average jerk. It is called average jerk. You may ask, what is jerk? I have not studied anywhere, not in the books also given, but jerk is nothing but rate of change of acceleration. Jerk is rate of change of acceleration. Okay, which does not have much applications in kinematics, but in dynamics it may have application, because if acceleration changes, so force also changes. So it may be related with uh, force or rate of change of force. Okay, but what about the area under graph? Let us take area. What is the meaning of area? In this graph, it is a dt, and acceleration can be written as dv by dt. Dt will get cancelled. So actually, it is integration of dv, which gives us delta v, change of velocity. So note that area under acceleration time graph, integration of a dt, will give change of velocity. So now we can see so many applications, right? So different graphs have different meaning of integration, but the meaning of integration is area, but in different context it will have different meaning. For example, you see acceleration time graph, it gives area will give us change of velocity. Velocity time graph area gives displacement. Okay. Similarly, let us take acceleration position graph, AX graph. Let us take AX graph. Here what will be the area gives? Try to check area. So integration of a dx. Now a can be written as v dv by dx, right? So here dx cancel. So you are going to integrate v dv. Let us say velocity goes from v1 to v2. Now the integration of v dv, we can apply the formula. So power of v is 1 here. So v power 1 plus 1, that means v power 2. So v power 2 by 2 you will get, and you can now put this limits v1 to v2. So put this limit, you will get v2 square minus v1 square divided by 2. That's the important idea. So area under acceleration position graph between the limits x1 and x2. This area, what does this area gives? And let us say when it is at position x1, it has velocity v1. At position x2, it has velocity v2. So this area under acceleration position graph gives us v2 square minus v1 square divided by 2. Right? That's how we can get. So different graphs have different meaning of area and different meaning of slope. Right? These are the applications. Right? So now using these concepts, we can definitely solve problems of kinematics. Kinematics questions can be easily solved, right? So, but what else is there? So that's not that much only we should know. Let us take few applications oriented questions and we can try that. Okay. Suppose this is the graph of velocity time graph, and velocity time graph is given as a parabola. V is equal to t square, and they ask between time 0 and time 10 seconds what is the displacement. Find displacement find displacement from time 0 to time 10 seconds. If they ask to calculate displacement, so what we know that this is velocity time graph, the area gives displacement. That means we need to do delta x. We want delta x directly, you write it as velocity, integration of velocity with time, and this limit is from 0 to 10. And here velocity is given as t square. Substitute this and go from 0 to 10. Substitute. So t square integration is t cube by 2. And you have to go from 0 to 10. Substitute upper limit 10 cube by 3. Substitute lower limit 0 cube by 3. So you got the answer as 1000 by 3. That's the displacement. Let us say it in meter. SI unit meter. So that's the answer, 1000 by 3, nearly 333. 333 meters. Right? Clear? Now, today I am going to discuss a very important question on this. Now, because you know the idea of slope, idea of area. That means you know what is meaning of integration, you know what is meaning of differentiation. Let us try to understand a very important question. Although this question looks like to be a very tough question, actually the question is a tough question. It is an international Olympiad question, and this question we are going to solve today using this concept. Only thing is that we have to keep little patience. A little patience is required to solve a problem. So that question I am going to discuss first. Okay, let me discuss that question. And with this question, we will be winding up this session. So today only one question, but this question is worth 10 questions. If you really understand the level of this question. Okay, so let's discuss that. Okay, so let's discuss this question. It's a very interesting question. This question is, related with a story that all of you have studied. All of us have studied this story of a hare and a tortoise. Yes, all of you have studied the story of a hare and tortoise who want to race. They want to take race. And all of us know that tortoise is not going to win the game. Tortoise is going to lose it. But that tortoise is quite, um, hard working person. Okay, I will fail. What does it make? Let me participate in the game. Like that mentality should be there. Even the question may be difficult, you have to have the mentality of the tortoise. Let me try. Let me try. The question may be very tough. Let me try. Okay. Like that, it is a story. They are participating in a game of race, and whoever will win, right? You know who will win. So tortoise goes very slow, and hare jumps and he goes very fast, very fast. But the question is not the same old course. I mean, story. Little bit change is there in the story, right? So, but let us understand this. What happens? So, suppose this is. I am not, of course, going to draw the exact diagram, but just a block diagram I will draw to understand this, right? So, suppose this is tortoise and this is hare. Both starts the race. Both starts the race, and the speed is going to be constant. I assume that the speed is constant. The speed is constant, and they are going in the same straight line, right? Same straight line they are going. And this hare is going with VH. This is hare, right? Hare means like a rabbit, right? And this team is tortoise. Tortoise. It is going with a velocity VT. So definitely when the game starts, you know what happens the story. The tortoise is going slowly, slowly, slowly. But the hare goes fast, 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 very fast he goes. You know the story, and everybody claps because he wins. But the thing is that when hare goes very far away, when he sees, oh, tortoise is very, very much behind me, then let me relax. By the time when he will come, then I will again beat him. Already I have beaten him. Let me eat something. Let me enjoy some food stuffs, and let me take rest also. I am tired. I am overconfident that anyway I have won that. Again when he will come, I will see him and I will leave him again behind. Already I have left him behind, right? So he stops and he eats food and he sleeps near a tree. So let us say that there is a tree here. There is a tree. And on the top of the tree there is a monkey. There is a monkey is there. Monkey. Okay. And this here reaches and he sleeps, right? He sleeps. And when he eat food and he sleeps, he go in deep sleep. He doesn't notice also where is the tortoise. He doesn't wake up, right? So tortoise went more far than the hare. So hare remains here, but no, what happens? This tortoise goes, and let us say tortoise has come very, very far away. I'm just giving one example here. Tortoise has come here, but the monkey, the naughty monkey, plucked some fruit or something, and he dropped uh, to the ground. By the noise of that, this hare wake up. This hare now wakes up. So as soon as he wake up, he see where is the tortoise? I don't see it behind. But he see far away. Oh, tortoise has gone very far away. How much it is? Some distance it is. Let us say this distance is x naught. Right now, this is the hare. Hare wake up here, and he wake up. Okay, wakes up. Let us consider this time as 0. Now this is the story of this question. This question has this story now. That old story everybody know that. Now that old story is what? The tortoise won, right? And he lost because he was in deep sleep. So he lost. But let us now consider the new story after this. So as soon as he wake up, now he want that I have to again run and I have to defeat tortoise because anyway he runs faster, na, he can cover up. But he finds the distance x naught. Tortoise is x naught ahead. Okay? So tortoise is also smart. He is coming slowly, 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 but he did not make any noise. Who made the noise? The monkey. Monkey made the noise. Because of that, he woke up. Okay. So now what is going to happen is he is going to now. He thinks that I don't want to lose. Otherwise, people will laugh at me. I am the fastest. I can easily defeat him. So let me again try to overtake him. I want to overtake him. Okay. So he wants to overtake him. So what he does, what he will do, he try to overtake this distance x naught. Same distance he try to cover, but he takes a time of t1. He takes a time of t1 to overtake that. So the hare overtakes, the hare overtakes it. But you know what happens? What happens? He will try to overtake him, but it will take some time t1. But by this time t1, this this tortoise will not remain, right. He is walking slowly, slowly. So the tortoise will move away. Tortoise will definitely go ahead. So tortoise, what happens to tortoise? So by the time this comes here, tortoise also moves some distance. He's also smart. He doesn't wait, right? Tortoise knows. Now tortoise came to understanding that, oh, that has woke up, right? And he's anyway I am going to lose. Let me try, because he knows his speed is very less. So by the time he moves from here to here to cover up this distance, he moves further in the same time. In the same time, t1, he moves a distance x1 ahead. But when the hare comes here, he finds that he has moved x1 distance. He again try to cover that x1 distance. So to cover that x1 distance, this tortoise and this hare moves further this distance x1. But now this time he takes another time t2 to cover up this distance x1, right? So to cover up this distance x1, he takes time t2. But when he walks from here to here in time t2, this also moves forward, right? This also moves forward. This moves forward and it comes here in the same time t2, he moves a distance of x2. So like that it happens. So when it comes here, he finds that it has already x2 distance away. So he again tries to cover up that. So to try to cover up this distance x2, he takes a time of t3 and he comes up here. But when he comes here, what he finds? He finds that in the same time t3, it has also moved ahead by a distance x3 in time t3. So like that process is happening, like this process is happening. Now the hare will again try to cover up x3 distance, right? In that time will be t4 he will take, and like this phenomena keep on happening, and definitely the hare will capture, the hare will overcome it. So let me explain this question again, because some of you just now join it. So it's a very interesting. No, the class started at 9:30. Actually, class was I have already messaged and pinned also the timing. If you see that, okay. So okay, no worry. I will explain this question. It's an interesting question for all the students, whether it's JEE or NEET. It's a question of international Olympiad level. It's like a JEE advanced question. But how to solve this question using graph? Because graph involves what? Slope, that means dy by dx. Graph involves area, that is integration, right? So this question I am discussing to understand the feel of area or the slope, right? Let us see that. I will again repeat this question. The question involves the old story of tortoise and hare who are trying to do a race, right? And tortoise go very slowly, you know that, and hare goes fast. So story means it starts like this. So they starts running, and hare goes very very far away, very far away. He goes and he sees the tortoise is very behind. So he thinks that Anyway, I have lot of time. Let me take some food and let's take rest. By the time when tortoise will come here, then I will again wake up and anyway I will defeat him. So he sleeps here, and in the tree there is a monkey who is also watching these things, right? So this hare, when this hare wake up, he finds tortoise ahead of him, because tortoise is smart. He is coming but without making any noise. So he went ahead. You know who made the noise? The monkey made the noise. Monkey told her, "Come on, wake up." Tortoise is running slow. He has gone already ahead. Come on, wake up. So then he wake up, and when he wakes, let us consider this time 0. This is the time 0 when he wakes. So he finds tortoise x naught distance away from him. So he tries to overtake him. So he tries to cover this x naught distance in time t1, but by the time he will cover x naught distance, tortoise is also moving. So tortoise will travel a distance of x1 in the same time t1. So when he reaches here, he sees that tortoise has already moved x1 distance. So again this hare will try to cover this x1 distance, but this time he takes a time t2. So but in that time t2, this tortoise further moves x2 distance. So now hare sees that he has already moved x2 distance. I need to cover that x2 distance. So this time he will take time t3. But in this time t3, the tortoise again moves x3 distance. So like that thing is happening. Okay. So this tortoise is moving continuously. Hare is also moving, but hare is behind him. Right. So hare covers this distance, but by the time tortoise also move ahead. But you know he is going to defeat him because the hare is running faster. We know that its speed is much large than the tortoise. We know who will win the game. Everybody knows, all the world knows that because this is a new story, right? So in this story, definitely we know hare will win because he has woken up and he chasing the tortoise. Definitely he will win that game. So the question is what? The question is given, some information is given. I will write the values. Okay. So they have given the value of x naught. X naught is 10 kilometers, and they have given x3 also given. X3 is given as 0.08 meters, and time t7 is given 1.28 into 10 to the power minus 7 second. Okay, these informations are given, and the question is how long after the hare wakes up, how long after the hare wakes up will it win? How long after he wakes up will he win? If I give this question to you to solve it, you will definitely take lot of time. You may try to make up some equations. So I have given one day to the grade 11 students. None of them solved it. None of them solved it. Okay, for one batch I given 2 days, and for another batch I given 1 day. Topper batch I given 1 day, but nobody solved it. Okay, the question is a very interesting question. Okay, with this information we have to solve it. How to solve it? So if you want to write equations, you can write equation. You can do that. What equation you can write? So you can write speed formula, right? So this is moving with a speed vh, and tortoise is moving with a speed vt. You may try to write this speed. So vh you will write as what? Speed is distance by time. He is covering a distance of x naught in time t1. This is same as this distance x1 by t2. Right? These things you can write. This distance x2, t3. Like that you can write. Okay. This is the speed of hare. Tortoise speed, if you write v of tortoise. Tortoise is covering x1 distance in t1. Then x2 distance is t2. Then x3 distance in t3. Like that you will understand, right? Like that you can write it. But from these two you know, things, what do you get? They have given x naught and x3. Okay, first let us think in a reverse way. What do you want to calculate? What do I want to calculate? I want to calculate the time in which it will overtake it. So for that you can apply the concept of relative motion. I think some of you know the idea of relative motion. So if you see this here is going with velocity vh, and this is tortoise which is going with vt. If you study relative motion means and the distance, initially the distance between them is x naught. So you know the time in which it will overtake, they are going in the same direction. So what is relative speed? What is relative speed? You know what is relative speed? Because they are moving in same direction, so relative speed will be vh minus vt. In same direction, when bodies are moving, you have to subtract the speed, and when the bodies move in opposite direction, we have to add the speed, right? That's what is relative speed. When two bodies, suppose two trains are crossing each other, you will see that they are running faster. Suppose one person is in a train, he will see the other person is running faster. But if the same train goes in the same direction, he will see that other train is running slower, right? So that is because of relative speed. So if they are going in same direction, so relative speed is the difference. So if I want to calculate time, so time to overtake, that time is equal to distance, which is x naught, by relative speed, which is vh minus vt. This simple formula we have to apply to solve this. So the only thing that we don't know is vh or vt, both. So we need to calculate the speeds of hare as well as tortoise. Then we will subtract and we will get the answer. Okay. So how to do that? That is the main problem of this question. That is the main problem of this question. How to calculate VH and VT, and I am going to give a very intelligent method by which you can solve it. You try to even search out the solution. They have not done by graphs. This only I have thought about it. You can make equation and solve, but the thing is that the visualization will not come. Why should we do it like that? The visualization is given by the graph only. Okay, graph gives the visualization. So let us try this by graph. Okay, let us take graph and try to understand this. Suppose I am going to draw position time graph, xt graph. Xt graph, I draw position time graph. And let us consider that time 0, this is the here. And at time 0, the tortoise is already moved ahead. So this is the distance x naught, right? Tortoise is already x naught distance ahead. So this here wants to cover up this distance. So to cover up, he is traveling in a time of t1, right? And in this time t1, he has covered this distance x naught. See, when I am drawing this horizontal and vertical line, this horizontal and vertical line is not the graph. Okay, this I am drawing the interval to get the idea of how the graph looks like. Because I want to plot, and note that graph will be a straight line because why? What is the slope of this xt graph? Just now we discussed what is the slope of xt graph. Xt graph slope gives velocity, right? Velocity dx by dt, that is the slope of position time graph, that gives velocity. And because velocity is constant, the constant velocity means constant slope, which is a straight line. So position time graph will be a straight line whether you are drawing the velocity of tortoise or if you are drawing the velocity of hare. Okay, so it will be a straight line, but this I am doing to get the points on the graph. Okay, so suppose if you take off the hare is covering this distance x naught in time t1, so you will be getting this point here. So this is point here and then this point here. Then within that time, in the same time, t1, the tortoise goes some distance further, right? That distance is x1. So tortoise will come here after this. So tortoise was initially here, now it is here. Then again, what happens? So now here we'll try to overcome this x1 in time t2. In time t2 it will overcome this same distance x1, it will overcome. So here will come here, but the same the same in the same time t2, the same time t2, this here will overcome, or sorry, this tortoise will go move forward a distance of x2 like this. So you can see that this type of graph will happen. Now further, you think more, try to draw more. So again, for the hare, he has to again cover x2 distance. So to cover x2 distance, he takes time t3, and he cover up this x2 distance. But when he comes this x2 distance, he finds tortoise again moving in the same time t3. Same time t3, it moves a further distance of, you know, x3. Like that, this story keep on happening. So let me join those points which are for the tortoise and those points which are for the hare. Okay. So I am going to join these points. First, these points represent the uh, positions versus time for this. These points for what? For hare. So let me join these points like this. So this straight line represents the velocity of the hare. Now, if I join these points, the different graph I will draw. These points. These points I am drawing with a straight line. So this represents the velocity graph for tortoise. Clear? And you can see that these two graphs are going to, they are straight line and they will coincide. They will meet somewhere, right? They will definitely meet somewhere. That is the time we have to calculate when they will meet. So how to do this? Right? So you take this angle. Now try to understand. Suppose if I am taking this angle as theta 1. So all these angles will be theta 1. That's an interesting thing to note, because this is the same line. It will make the same angle theta 1, and this tan theta 1 is giving us the velocity of the hare. Similarly, this line if you take, it is making theta 2, theta 2, theta 2, right? So this theta 2, tan theta 2, this tan theta 2 is the slope of position time graph for which? For tortoise. So this gives velocity of tortoise. Okay. Now you have got it. Now, very important, how to solve the problem. You need to look. That's what the graph is, something which can give you visualization, and a very simple maths of grade 8 and 9 can be used to solve this problem. Okay. That is a very interesting thing. The maths of 8 and 9 will help to solve the problem. Okay. So now you see, first of all, see the graph, these triangles you see, these triangles, yellow color triangle, this triangle is for hare. So in time t1 it is traveling x0, in t2 it is traveling x1, in t3 it is traveling x2. So figure out that all these triangles are going to be similar. First of all, you have to agree that all these triangles are similar. Why these triangles are similar? Because first of all, these angles are 90, 90, 90, and these angles theta 1, theta 2. So if these two triangles, if two angles are same, that is a similar triangle. Ah, triangle angle property. So these triangles are similar triangle, and also you know that the slope is constant, means this ratio is constant. Suppose if x0 decreases by some factor, t1 will also decrease by same factor. Suppose for example x0 decreases and becomes x1. Let us say x1 is half of x0. Let us say that x1 is half of x0. So t2 is also half of t1. That we have to understand. Clear? So that means they are decreasing by the same factor, and it is decreasing because side is becoming smaller. So if this side becomes smaller, this side also becomes smaller, and the ratio will be same. So if I say that I am making a series, okay, x0, x1, x2, x3, like that. So x1 is smaller than x0, x2 is smaller, x3 is smaller, but the ratio will be same. Ratio will be same. That means x1 by x0 ratio is same as x2 by x1 ratio is same as x3 by x2 ratio. Like this it will happen. And all this, let us say the ratio is r. Let us say that ratio is r. Okay. So similarly, this ratio time T1, T2, T3, T4, this will also be forming a similar pattern, and these ratios of time T2 by T1, ratio of time T3 by T2, ratio of time T4 by T3, these ratios are also going to be same as equal to R. Yes? Clear? First you have to agree to this. Why? Because these sides are decreasing in the same way, right? Same. If this become half, this will also become half, because these two triangles are similar. Not two triangles, all these triangles are similar. Okay. So these sides will decrease in the same ratio. Now what is that R? We have to note that what is that R, that will calculate. But let us first try to write them as geometric progression. Geometric progression will write. Why geometric progression? Because if x naught ratios are same, then I can write this series x naught r, x naught r square, x naught r cube. We can write, correct, because r is the factor by which it is decreasing. So I will just multiply r, next term I will get, right? That is what is geometric progression. Okay, and same thing we will do in this T1 also, time series. So let's say T1 is the first term, next will be T1 into r, next will be T1 into r square, next will be T1 into r cube. Like this it will form, right? So r is the ratio, that is called common ratio, right? Common ratio in geometric progression. So both of these are in GP. Both these are in GP with the same common ratio they are. Now let us try to calculate that common ratio. Now you see these two different triangles. One triangle is for hare, other triangle is for tortoise. See that? Let us take this velocity VH. So for this triangle VH is nothing but tan theta, which is x naught by T1. X naught by T1. And similarly take tan theta 2, that is Vt, that Vt is equal to x1 by T1, x1 by T1. Now if I take ratio, for example, I need ratio R, right? I need to find R. So R is the ratio of the R is what? X1 by x0 ratio. So let us calculate x1 by x0 ratio. X1 by x0 ratio. So what is x1 from here? X1 is Vt into T1. And what is x naught here? Vh into T1. So you see T1 get cancelled. T1 get cancelled, right? T1 get cancelled, and what you get is this ratio is Vt by Vh. And this is what we are calling as R. That is what we have to know. This x1 by x0, or no, next term by previous term, that is what is R. Now, once you got this idea, what is that R, which is the ratio of velocity of speed of tortoise and speed of hare, now you can approach this problem, because they have given information in the question x3 and t7. So let us write x3 according to this series. Let us write x3. What is x3? Tell me. Note that this one is x0, this term is x1, this term is x2, this term is x3. Right, this term is x3. So x3 is what? X3 is x naught r cube. Yes. So once you know this, they have given x3, they have given x naught, r we can calculate from here. R we can calculate. So r cube becomes x3 by x naught. Yes. Now let us substitute the values. They have given that. So r becomes cube root of this x3 by x naught. So x3 they have given in the question 0.08. 0.08, and this x naught is 10 kilometer. Let us keep in meter. So 10 kilometer means 10,000 will take. Okay. So solve this. What is our? So that will become 8 divided by 3, 4, 5, 6, 10 to the power 6, right? power 1 by 3. So cube root of 8 is 2 and cube root of 10 power 6 means 100 it will be, right? Take that into 200, yes. So that becomes 0.02. 0.02 ratio it is. So this ratio we got 0.02, very good, we have got that. Next they have also given T7. Let us write T7. According to that, what is T7? This is T1, this is T2, T3, like that it will go. So what is T7? Can you tell me what is T7? What is T7? T1 into R power how much? Can you tell? T7 will be how much? Anyone? Sam? 6 only, correct. Because you have to subtract one T2 in T2, T1 into R power 2 minus 1. Third T3 is T1 into R power 3 minus 1. So here it will be 7 minus 1, correct? So it will be T1 into R power 6, right? That is what is T7. So now I will substitute here R and we can calculate T1. Let us calculate T1 from here. So T1 becomes T7 by R power 6. T7 they have given, I think I have written the values for that. Let me write it. T7 is 1.28 into 10 to the power minus 7 divided by R power 6. R we have now calculated, now substitute 0.02 power 6. So let's remove the decimal, so that is 128 into 10 to the power minus 9 it is, because this 100 I taken numerator, and this is 2 power 6 into here 100, 10 to the power minus 2 is there, 10 power minus 2 into 6, 10 to the power minus 12. Check out this calculation. What is 2 power 6? 64, and 64 into 2 times, right? So this will get, yes, yes, 10 to the power 3. Correct, right. So we got T1, this much second. Okay. So T1 we got R and T1 we got. Okay, now can we calculate velocities VH? Let us see. VH. We have got T1, right? Now we can calculate x naught by T1 is VH. Okay, x naught by T1 is VH. So VH is x naught by T1. X naught is 10 kilometers, so 10 into 1000 by this is 2 into 1000. Right? That get cancelled, it become 5, right? 5 meter per second. That is the speed of the hair. Hair is going with that speed. Okay. And now we know already that this Vt by Vh, that is the ratio R, correct? So now we can calculate Vt from here. Vt becomes R into Vh. R is 0.02 into Vh, just now we have calculated as 5. So how much is Vt? 0.1, right? So we got now game is over. We know how to calculate time. Let us calculate the answer time. Time to overcome. Time to overtake. That time to overtake is the distance x naught divided by Vh minus Vt. Relative distance by relative speed 10,000, right? And Vh is 5 minus 0.1. This answer, now we can do the calculation. Check out this. You can approximate, but this is 4.9. Now you calculate. So this is nearly 10, 100 into 1,549. Nearly 2000, but do exact calculation, that will be better. Okay, do exact calculation. What is the answer? Two zero four 0.8 nearly. Okay. If I round it to integer, then it will come nearly 2041 seconds. Second. And in minutes, if you calculate this, you can divide by 60. Nearly 34 seconds it comes. 34 minutes, sorry. 34 minutes. Yes, that's the answer. That is the answer of this question. That's a good question, right? Calculations are involved. And the graph helps us to solve that. So if you draw the graph, definitely you have the advantage. But without graph also you can solve. I'm not saying you cannot solve. But for that you have to write equation and you have to make the pattern. And to make the pattern, after that you can solve. But from the graph we can see the triangles are decreasing in their size. So that is giving us an idea that there is a common ratio for both the side. One of the side represent time, another side represent distance. So both are decreasing in the same manner. That idea helps us to solve this problem. Clear, right? We will discuss that. So now we are going to wind up this class, right? So grade 11 class, now we are going to wind up. Okay, so let me wind up this session. So next grade 11 we will continue. I think we have covered differentiation, integration, then we'll go for problems. So one class I will take where I will discuss all the important types of questions based on the applications of integration and differentiation before we go move to the next topic of trigonometry. Okay, so let us wind up this. I will